What's up friends? Welcome to the channel. In today's video, we will go over all the concepts you need about covalent compounds in iGCSE chemistry. If you would like to go over an exam question related to covalent bonds instead, you can check out a different video I will leave in the description box below. Let's go! First off, what is a covalent compound? Simply speaking, any molecule that contains non-metal elements only is covalent. If you need to refresh your memory on what counts as an element, I got another video explaining compounds, elements, and mixtures. Just click in the link below. So what counts as a non-metal? If we look over a periodic table and draw a zigzag pattern starting from aluminium diagonally going down, anything found on the right side of that zigzag line counts as a nonmetal. So examples of nonmetal elements include oxygen, fluorine, and nitrogen. Next, what is a covalent bond? A covalent bond is the attraction between the nuclei of two atoms and their shared pair of electrons. As the definition mentions, electrons tend to be shared between elements in this compound, with every pair of electron representing one bond. So covalent bonds can be found as single bonds, like in water, double bonds, like in carbon dioxide, or triple bonds, like in nitrogen gas. The number of electrons that needs to be shared depends on how many electrons it takes for all the elements to be satisfied with the octet rule, which implies that elements need 8 electrons in their outer shell to be happy. The exception to this rule is hydrogen. It only needs 2 to be happy. Let's use water as an example. Water contains 2 hydrogen atoms and 1 oxygen atom. If we look at the oxygen atom, it has 8 electrons altogether, with 6 electrons in the outermost shell and 2 electrons in the inner shell. The hydrogen atoms don't have as much, only 1 electron. This means that the oxygen needs 2 more electrons to be happy, and each hydrogen atom needs 1 more electron to be happy. So we can play around with this. Hydrogen cannot bond to the other hydrogen because you will be making hydrogen molecules in this case, and the oxygen will be left out. And if we bind 1 oxygen atom to 1 hydrogen atom, hydrogen may be happy, but not oxygen. This means the only way to arrange the atoms will be to have our oxygen sandwiched in between our 2 hydrogen atoms. Once we know how the atoms are arranged, then we need to figure out how many electrons each atom will share. As mentioned earlier, oxygen has 6 electrons in the outer shell. This means it has 2 electrons that it needs to share, so it will want to get 2 electrons back. But it has to share 2 electrons with hydrogen atoms, so it will share 1 electron with each hydrogen atom. In turn, each hydrogen atom will also share 1 electron with the oxygen. This gives us 1 pair of electrons being shared between each oxygen and hydrogen pair. In other words, our single bonds. And there we have our water molecule. We can use this method for other molecules like water, methane, ethane, ethene, and the list goes on. If you would like to have more examples of covalent compounds and their dot cross diagrams, let me know in the description box below. Now that we've looked at your covalent bonds, let's have a look at the covalent structures. We can split the covalent compounds into 2 groups, your simple molecular structures and your giant covalent structures. Simple molecular structures are structures such as water, carbon dioxide, and nitrogen. They tend to be gaseous in state or liquid in state. They also tend to be poor conductors, as well as having low melting points and boiling points due to their weak intermolecular forces that take very little energy to overcome. Some exam words right there. Giant covalent structures, on the other hand, are substances like diamond and graphite, which tend to be solid at room temperature. Diamond, being the strongest allotrope of carbon in the world, has a really high melting point due to each carbon being bonded to 4 other carbons. This results in a lot of energy being required to break these bonds. Graphite, which is the other giant covalent molecule, has a moderately high melting point. Now, what makes graphite special, though, is the way the carbon atoms are arranged. Because they are arranged in layers that kind of look like a honeycomb or a beehive, the delocalized electrons are free to move around. And because of this, graphite can actually conduct electricity, and which is why it's used as electrodes in experiments such as electrolysis. In summary, covalent compounds are compounds that involve non-metal elements only, and a covalent bond is the attraction between the nuclei of 2 atoms and their shared pair of electrons. Their structures can be divided into 2 main groups, your simple molecular structures and the giant covalent structures. Their simple molecular structures can either have a single double or triple bond, or a mix of any of these three. For example, your ethene. The giant covalent structures refer to either diamond or graphite. Quick word before we go. Can I ask you a favor? If you found this video useful, can I ask you to subscribe to this channel or like this video? It would help the channel grow, and in return, I will make sure the bigger the channel gets, the better the content gets. Thank you for watching, and I hope to see you in the next video.